All right, Mark again, and I'm here for the Mark Rober's monthly class. This is going to be for project number 3. And in this one, we've got to do something that enforces a habit, teaches a skill, something along those lines, and uses all of the skills that we've learned. And I'll tell you right now, I'm not feeling great. Got a little bowel obstruction, so forgive me if I lose my train of thought here. Um, anyhow, back when I was a kid, I was really into electronics and I got my amateur radio license. And one of the things that came along with that at the time was you had to learn Morse code. And I had a key similar to this one. But it wasn't exactly this one, but I had one similar to it. And I used it to communicate with people all over the place, all over the United States, Canada. Sometimes, they would be very, very far away. I remember I was really excited about the fact that one time I talked to a guy in Australia. Now, 16-year-old me talked to a guy in Australia. 43-year-old me knows that I talked to a guy who said he was in Australia. I mean, he could have been 2 states over for all I know. He didn't have to be very far away. He couldn't have been too close, or the signal would have been a lot louder. But it's still pretty cool, regardless of where. I talked to enough people far enough away that that I thought it was neat. I had a little a Yagi antenna up on top of the roof and a little rotor, and I could aim it and direct it, and do my little communications and get my little cards, and it was fun. I've long since forgotten that skill just because it's perishable. If you don't use it, you lose it. But I thought it might be kind of fun to get back into that. So I thought for this project I would create a decoder, something that will take Morse code audio and put it on an LCD screen. Now I know what you're thinking. Yes, that one is a little bit bigger than the one that came in the kit. I don't know what to tell you. The older you get, the blinder you get. And it's nice having more data visible. It just, you have to pay less attention. It becomes a plus as you get older. Anyhow, it works just the same. I mean, same hookup as these, just the pin, 16 pins, 16 pins. Same thing, just a different form factor. You can display more data. So, we've got to get the audio, which comes in as a series of, dots and dashes. It is, a little sound. Beep, 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 beep. That type of thing. You've probably heard it on the radio or seen it in movies at some point. So, how do we go from audio that's going to be coming out of a radio into a screen? And there's actually quite a few ways to do it. So the first thing that we've got is, our little radio, which I don't know if there's a schematic symbol for a radio, but we'll just draw one here. It's going to have some dials on it and some buttons. And most importantly, it's going to go to a speaker. And you'll forgive me if I lose my train of thought here. I've got a little bit of a bowel obstruction and hurts a little bit. Anyhow, from the speaker, we're going to have to hook that up to a microphone. And from the mic, I guess we should label these. We're going to more than likely need to go into a amplifier of some sort, depending on how loud this stuff comes out. I mean, it's also possible that we have to put this thing through an attenuator of some sort. I don't really know. I can do that. I mean, I can do the circuits for these easy enough. Just an op amp and a a logarithmic potentiometer. I mean, it's not that big a deal to me, but we need to get that audio and digitize it somehow. So the general way that you do that is with something called an ADC, an audio to digital converter. Those things are, I mean, there's lots of different ones, delta sigmas, approximation. It doesn't really matter, but you basically just take that thing and digitize the signal that's coming in. And it's possible that we can do that right through the Arduino. I'm not entirely sure. We will have to figure that out. But at that point, instead of having, audio signals that are traveling through the air and, look like a bunch of waves, by the time we get over here to our little magic ADC black box, what comes out is a series of ones and zeros at that point. Now, that by itself isn't too useful, right? You've got all of those ones and zeros, but no way to really do anything with it. You've got to do some signal processing. And for that, so do we want to do DTMF2 and CW? Let me just make a quick note to myself here. So really what we should be seeing, if we tune this right, and especially if we put in a filter, we should be seeing blocks of data, actually, for CW type stuff. So it's possible if we just, at that point, just run it through a debouncer, at that point I should just have blocks. But the issue would be that we don't know necessarily the speed that these things are coming out. So we would have to do something programmatically to determine what the what ends up being a dash and what ends up being a dot. But that is all code at that point. Then from there, after we do figure out what's a dash and what's a dot, at that point we would run it through just a lookup table. That says, if you've got 2 dots and a dash, it's this letter. If you've got a dash and 2 dots, it's this letter. So you would just have a Morse code, and forgive me, I don't remember what these things are. I think C is actually that, but I'm sure that's not B. That's actually S. Oh, well, maybe I do remember more than I remember. Anyways, you would do a lookup table, and at that point, you would go to the display, and you would pluck out your message. Now, I don't have really time to do this circuit. I mean, I've got parts. I could breadboard it. It'd be nice to put in a notch filter of some sort. So that's just an arrangement of resistors and capacitors that you put in to filter out unintended frequencies, things that you don't want to hear, because there's always noise in any signal. And the cleaner you can make it, the better. But I was also thinking another something that happens is this thing called DTMF, dual tone modulated frequency, and that's like your telephone keypad. It makes those weird sounds. Beep beep beep, but whatever. It's actually two frequencies laid one on top of another. And there are electronic circuits that can decode those and filter them out. I don't have those ICs. I'd have to order them. I don't have time for that. But it is conceivable that if you took it at this point and you decided if it was one frequency or many, you could run it through this thing called a Fourier transform. And basically what a Fourier transform does, it's called a fast Fourier function, but you take your component signal and it'll know that inside there you've got one frequency at this amplitude, another frequency at this amplitude, and yet another at. So it's possible that we could programmatically make something that can decode the CW, continuous wave, which is probably the easiest thing to decode, and the DTMF. And you see DTMF on audio calls. People will use those as ANI tones, automatic numerical identifiers. So you know what station you're talking to. So it seems then that, getting stuff out on an LCD is easy peasy. It's not a problem at all. Decoding, yeah, there could be a little trick there, especially if we end up doing any sort of error correction. I don't know if I certainly won't by this end. Just not feeling like it right now. And then going from the digital to data that's useful for us. That'll be a little bit of a trick too, especially since these things can be transmitted at different speeds. So with that, I pulled out a couple of things from my arsenal. The first is the brand new Raspberry Pi, and I think I can bring up a better image here for you. Let's see, overhead narrow is 4. Let's try that. Okay, so this is the Raspberry Pi Pico. This has a Cortex M0. It's actually got 2 separate processors in there, so we could use one to run the display and maybe the Fourier transform, and another one to run the lookup table. You could do some interesting things programmatically. And then I also found this is something called I2S. It's a communication protocol. Integrated sound is, I believe, what it stands for. But basically, this does the the analog to digital conversion for you. So this shoots data back to the Pi. Now, the issue is that this doesn't have a I2S machine in it. It's got no way to communicate with the I2S protocol. However, it should be relatively trivial to just create your own state machine. Use the PI, and again, I'm just not feeling good today, but it should be, I wouldn't call it trivial, but easily accomplishable to reprogram this IC to create the protocol that's missing, that it doesn't have natively built into it. So that's not a big deal. And then I also found this guy, which is still a digitizer, but you can do line in. So you would you would just run a cable from the back of the radio into this, and then you don't have the audio, blasting through the house. It just gives it to you. But the trouble with that is then you don't learn it, you don't. It's a shortcut, but it's doable. I mean, it's no big deal. Then I had another idea. This guy is the Arduino BLE Sense. It's got a, if I remember correctly, a Cortex M4, so it's got more commands that it can do. And on here, there's a microphone built right in. So I don't have to do anything. I can just do the whole thing here. I would just have to hook up a display. And it's got the BLE protocol built in, so, I mean, theoretically that display could just be my phone. But, I mean, I do know how to implement the BLE protocol. That part doesn't scare me. What scares me is that if we do it this way, then you've got to dedicate your phone to it. I would prefer just to have it running the whole time. But this should have everything we need right on board. That's an option. I mean, there are even FFT libraries for the Arduino, for the ATmega 328P, and something called the Hartley, the fast Hartley transform, which is even less processor intensive. But wait, there's more. Although I don't know if I have it lying handy. Oh, that's a shame. I was going to make fun of another device here real quick, but I don't know where it is. Anyhow, so I think that's going to be my thing. But whether or not I get this done on time is going to be predicated by my energy level and how fast this resolves, because I know we are on an accelerated time scale. But nothing is too scary here. Everything's pretty easy to do. I wouldn't say too easy to do, but everything's doable. 100 lines of code, maybe, give or take 50. I mean, it's not going to be much. There's going to be libraries for the display, so I don't have to do anything there. All I have to do is just wire it. It's easy. If I run the RPi Pico, I would have to, I mean, it's possible somebody's done an I2S library at this point, but I doubt it. It's, well, I don't know. It's been out there just long enough that somebody might have. And then I need to implement either a Hartley transform or a Fourier transform if I want to do the DTMF. If not, I just basically treat each signal as a switch press and decode the switches. You know, it's like decoding a secret knock. Do that with the lookup table, and off you go. I might have to, if I can't figure out how to do it programmatically, I might have to incorporate a switch to adjust for speed of transmission so that it knows the difference between a dot and a dash. But that should be about it. All right, I guess we'll get this uploaded, and we'll see y'all in the forums. Take care.